Space is vast, mysterious and full of extremes, but among all the strange and powerful things in the cosmos, nothing compares to black holes. They are the most terrifying objects in the universe, capable of warping space and time itself. They have no physical size limit and can keep growing endlessly. Some are so small they could fit in the palm of your hand, while others are so massive they could swallow entire solar systems. But what exactly determines their size? How do black holes grow? And most importantly, what is the biggest black hole we've ever found? Today, we're diving deep into the ultimate cosmic monsters, from the tiniest to the truly unimaginable. This isn't just another space video. This is a journey through the extremes of reality itself. Let's start at the smallest scale possible. If black holes can grow infinitely large, can they also be infinitely small? Theoretically, yes. Some scientists believe in the existence of primordial black holes. These would be the oldest objects in the universe, forming in the first few moments after the Big Bang. The early universe was a chaotic, high-energy mess filled with dense regions of matter. If any one of these regions became just slightly denser than its surroundings, it could have collapsed into a black hole. The smallest possible black hole that could still exist today might weigh as much as a mountain, but be smaller than an atom. If one had the mass of Earth, it would be about the size of a coin. If primordial black holes exist, they might actually be the missing dark matter that holds galaxies together. But since they would be so tiny, detecting them is nearly impossible. However, we do know that larger black holes exist in the universe today. The most common type of black hole is called a stellar black hole. These form when a massive star collapses at the end of its life. To understand their size, let's use our Sun as a reference. A stellar black hole can range from just a few times the mass of the Sun to dozens of times more massive. The smallest one we know of has a mass of 2.7 suns but is only 16 kilometers wide, about the size of a small city. One of the most extreme examples is M33X7, a black hole that's 15 times more massive than the Sun. It's slowly consuming a nearby star, and as it does, the gas falling in creates a glowing accretion disk 500,000 times brighter than the Sun. But despite their power, stellar black holes are nothing compared to the true behemoths of the universe. If black holes grow by consuming matter and merging with each other, you'd expect to find a steady increase in their sizes across the universe. But strangely, we don't. We see tons of stellar black holes, and we see supermassive ones, but there's a huge gap in between. Black holes in the 100 to 100,000 solar mass range are extremely rare. This is a problem because supermassive black holes are far too large to have grown from normal stellar black holes in the time the universe has existed. So how did they get so big, so fast? Scientists believe the answer may lie in a long-lost type of celestial monster. To explain how supermassive black holes formed, some scientists propose the idea of quasi-stars, the biggest and most extreme stars that may have ever existed. Unlike today's stars, which explode into supernovas when they die, quasi-stars collapsed into black holes while they were still forming. Imagine a single star thousands of times the mass of our Sun. Instead of exploding, its core imploded, forming a black hole while the outer layers kept feeding it for millions of years. This process allowed these black holes to skip the slow growth phase and jump straight to thousands of solar masses. If they existed, these objects would have been some of the largest single bodies in the early universe. And they may have been the seeds of the supermassive black holes we see today. Fast forward billions of years and now every major galaxy has a supermassive black hole at its center. The one in our own Milky Way is called Sagittarius A*, and it's 4 million times the mass of the Sun. That sounds huge, but compared to other supermassive black holes, it's actually tiny. Some, like the black hole in the galaxy Cygnus A, are billions of times more massive and produce gigantic jets of plasma that stretch for hundreds of thousands of light years. The first black hole ever photographed, the one in Messier 87, is so large that it could swallow our entire solar system. But even that isn't the biggest. Now we reach the true monsters. Black holes so massive they defy imagination. Take OJ 287, a black hole with 18 billion solar masses. It's so big that another supermassive black hole orbits it. But the biggest one we've ever found is Ton 618. This ultra-massive black hole has an estimated 66 billion solar masses. It's consuming entire galaxies' worth of matter, and its accretion disk shines brighter than 100 trillion stars. And here's the craziest part, Ton 618 is 10 billion light-years away. That means we're seeing it as it was 10 billion years ago. So, in reality, it's probably even bigger today. This might be the largest single object in the entire universe. Black holes are the ultimate cosmic survivors. Long after all the stars in the universe burn out, black holes will continue to grow. They will consume everything until the universe reaches its final cold and dark era. And the best part? We've barely scratched the surface. There are probably even bigger black holes out there that we haven't found yet. Could there be something even more massive than Ton 618? Let me know what you think in the comments, and don't forget to subscribe to FactXplorer for more mind-blowing space discoveries. Until next time, stay curious.